Welcome to Season 2 Purdue University College of Sciences Superheroes of Science podcast. I'm Stephen.
And I'm Sarah. We will be discussing anything and everything related to science. If you have a science question, tweet it to us at Purdue SOS, and we will try and find someone to answer it for you. Welcome to Superheroes of Science. We're here today with Caroline Kostak, Spacesuit Systems Engineer. So welcome, Caroline.
Thank you.
All right, let's start with, well, you've had a couple of careers in your career. Is that the way you're saying it?
Right.
And so let's start with what you did back at because after you did your degree, I want to say something engineering. Help me.
Chemical engineering.
Okay, chemical engineering. Which you would have thought I'd remembered because Sarah's the chemistry gal, and so she anytime anyone says chemistry, it's
Yep.
But all right. So you went with your bachelor's there, but somehow you ended up at NASA.
Yes, sir. I actually got a job with the United Space Alliance right out of college. So at the Industrial Roundtable, I met up with USA, the United Space Alliance, which no longer exists, but was the main contractor for flight controllers at Johnson Space Center. And I had known all through college that I wanted to work somewhere at NASA, and had kind of run into a bunch of dead ends, and wasn't thinking it was going to happen, and had a different job lined up. And then all of a sudden I thought, I'm just going to go talk to him one more time. And so at the Industrial Roundtable, I went and talked to USA, and they hired me actually on the spot. It was unbelievable. Yeah.
Oh yeah.
Like, they're like, you want to come to Houston? I'm like, yeah. They're like, you know what a flight controller is? I said, I have no idea.
Yeah.
I don't care. So yeah, I came down to Houston to be a flight controller, and I showed up at like the perfect time. It was right at the beginning of the assembly of space station. And so our job was actually, I just wound up in the group that did the operations integration of the assembly of space station. So we were the ones in the control center kind of coordinating, and I like to think of it like the conductor, like, okay, now you go, and putting together the big picture.
So you went, and so then you started without realizing for sure what that meant, and
I did.
And it sounds like.
Yeah, so as it turned out, I loved it. It was exactly the right kind of job for me. So I did flight control for Johnson Space Center for 12 years, and then left there when the space shuttle program ended. I thought maybe it was a good time to go take what I had learned at NASA, some really great integration skills, and take that out into the rest of the world and see where I could be useful out in the world. And so after that, I went and started a couple businesses, one of which was green building, residential green building. We had a hurricane, and I watched a bunch of houses being built and torn down, and that was really impactful for me. So tried to go change the way we build homes. So have been doing that for a couple years, and then some opportunities started coming up as we're getting some new programs back online. We're starting the new Moon program and a new Moon space station program. So NASA started calling me back. So I ended up going back, and now I'm working in the spacesuit area, integrating the spacesuits with the moon landers that are coming online.
Wow.
So yeah, that'll be fun.
Well, that's more directions than I thought. Where do I narrow it down? Let's start with a lot of grade levels for students in grades. One of the standards I have to talk about is the human's impact on the environment.
Yeah.
So, and I'm guessing the green building thing would fall directly under that.
Right.
And so, what are some importances, if that's a word, what are some important attributes of, like you say, with a building for it to be green building? How's that work?
Yeah. So we use the framework that I use is called LEED, and that's LEED, and that is a kind of a checklist that analyzes buildings on 7 different levels. So we talk about water efficiency, energy efficiency, how the materials are used, and whether what kind of chemicals are used in those materials, and then how you treat the site during construction, and then a couple other things. So we really look at those different aspects of a building and how the building is built, all with the goal of having buildings and especially in my case homes that are built with a lower impact on the environment than normal homes are.
So why is that an important?
Um, I think it was the one of the graphs in the documentary Inconvenient Truth really spoke to me right about the time I was trying to figure out what am I going to do when the shuttle program's over. I'm going to have to go do something else. I was watching Inconvenient Truth, and it showed the graph of like where like energy use and the impact on climate change.
Mm-hmm.
And it had different sections on the graph of like, different sections that we need to address in order to reduce that the impact. And one of those sections was the impact of buildings on the environment, energy use and water use. And I thought, well, my dad was in the building industry, and I really have always been interested in the construction industry. And I thought, well, I might as well just pick that one. I want to pick something that's going to have an impact on the world, and
Yeah.
that seemed like a good one. So I picked that and did what I could, and I'm still doing what I can.
Well, Caroline, next week, I think next week is Earth Week.
Yeah.
The way, yeah. And I've seen on a lot of teacher threads, just a lot of ideas, of course, now with this online learning and everything. In what you've done, do you have any suggestions for teachers about activities kids could do to surround their homes to kind of recognize Earth Day?
Yeah, absolutely. In fact, I just saw an email come by in my list, like doing a virtual Earth Day. But so I can look at that email again and give you some better ideas. But the things that come to mind off the top of my head are doing an energy audit of your home. So there's a bunch of like energy audit things that you can do on a website, and it's really educational, and you can actually get some little tools that help you understand the plug loads, how much your computers are all using energy wise. Kids can
Like
look
a
at the
kilowatt
energy
meter?
bills. Yeah, like yep, a kilowatt, and you can see how much your computers are using, and kind of compare your energy bills with this stay-at-home time frame with before, and see if your energy has gone up. And then if you wanted to get really into it, you could figure out how much an average like office building uses, and are we using better less energy being at home versus an office. I think that's something that we've been talking about. Also the chair of the U.S. Green Building Council in Houston, and we've been talking about like what is the impact of this whole pandemic stay-at-home thing on the environment. And there's been a lot of different levels of things that you can look at. So I think that's a real accessible thing for kids, like doing an energy audit of their house and seeing if they can get their parents involved as well.
Mm-hmm. That's a great idea. Yeah.
Yeah, I like that. What was it called? A while back, I remember. Maybe one or two remember is something about energy thieves, or they were calling like.
Energy vampires.
Yeah, that's it. That's it.
Yeah.
When they
Yep.
left like things plugged in and stuff that shouldn't be, and they're always. I mean, you don't need your I don't know TV powered up all the time. The little LED always on it, stuff like that.
Right. Anything with
Yeah.
like a power brick that like on your computer and stuff like that, that's drawing power even when you're not when it's not on. And so a real good idea is to have like have all those things plugged into a power switch, and then just turn it off at the switch when you're done, when you're not using it, and then turn that back on. I mean, you can do that with all your TV and all your devices that are plugged into your TV, the DVD player and all that stuff, and just turn all that off so it's not sucking energy when you're not using it.
Yeah.
Like,
Yeah, that's a good point. Mm-hmm. So now you've shifted into spacesuit system or spacesuit. Is this right? Okay, spacesuit systems.
Spacesuit Systems Engineering, yeah.
Uh-huh. So what does a typical day look like for you now?
At the moment, it's a lot of meetings, a lot of virtual meetings, and really a lot of the work that we do is coordination with a lot of different organizations. So we have our team of people that are working on spacesuits, and then we have our team of people that are working on the moon landers. And my job is to be kind of the go-between between them. So I need to learn as much about the spacesuit as I can, and then I need to learn as much about the vehicles as I can, and then make sure that the vehicles are going to have the right connections, have the right amount of oxygen and water that we're going to need, things like that. So my typical day doesn't sound very exciting, but it's a lot of meetings, a lot of coordination with people. I happen to love that. I like integrating, and I like, hey, did you hear this thing? And it's kind of a lot of rumor mongering and educated rumor mongering.
Wow.
But it's really fun to be able to especially right now when we're not in meetings together. I feel like I haven't lost anything. We're all communicating, a lot of people all at the same time. So that, and a lot of today I'm working on updating a document. So we have a document that details all the details of the new spacesuit, and a lot of things have changed in the last year. So we're updating that document. Actually, I'm doing a lot of writing, which is unusual for an engineer, I think. But it's actually, I always liked writing in school. So, and because it's unusual for an engineer, I happen to be one of the few people that's kind of good at it. So I get a lot of writing assignments, but I like that.
Oh, good. So where in the process of development is this spacesuit? Is there a prototype yet for it, or is it?
Yeah, so we have the spacesuit that we use on the space station, and that's a great spacesuit, but it's about 40 years old. And so we need a new one, just because we need a new one, and it's getting hard to manufacture those parts. So they've been working on an update for a while, but now that we're going to the moon, they announced back in March last year, so about a year ago, that we're going to the moon. So we've changed from just updating the spacesuit to really having a spacesuit designed for the moon. And so to be able to walk on the moon, you need to have boots that can work. Like the spacesuit that we use up on space station, you don't need to walk, you're floating. And so we need to have good boots for walking. We need to have a lower torso that can bend over. We need to be able to kneel. We need to be able to scramble a little bit. We need to have better gloves that are abrasion resistant, because the moon rocks are very sharp, actually. And so there's a lot of updates. Also, the suit that we use now on space station, your work area is like right here. You can't do things like this. You can't put your arms over your head, and you can't really do a lot with your shoulders. So we've made new shoulders that you can actually move up and down now, and do all sorts of things. So it's a much more mobile suit, which makes it a little bit heavier. So we're having challenges with that. But so we've actually designed 2 prototypes. You might hear about the Z2 and the Z2.5. Those are prototypes of the suit, but the new suit will, incorporate lessons learned that we've learned from those 2 prototypes. And we're going through a testing phase in the next year or 2 to develop the next suit. Pretty far along in the process.
Wow.
That sounds like a lot of variables.
Yes.
How many different people in different careers have to come together in order to design something of this magnitude?
Yeah, we have about 250 people on our spacesuit team, and a lot of them are designers doing a lot of detailed engineering work. Designing this one little part that's going to go into another part that's going to go on the suit. And then there's some people like me that are more like big picture integrator people that work on the interfaces between the vehicle and the suit. And then we also have managers, and then there's also we always have accountants and people like that are keeping track of the budget and things like that. So.
And that's amazing. And when we talk about engineering design, and we're talking to students about how it's always a team of people for backgrounds coming together, this is this is an awesome example of the.
Absolutely. Yeah.
Because it's pretty important what you guys are doing there. If one area of that messes up, you have someone's life, and of course billions of dollars.
And the life is the most important. But yes, absolutely, we are a little vehicle. And before I started at this job, I just had a little bit of oh my gosh, what if we screw it up? What if we do it wrong? And I was just so wow, that's a lot of pressure. And then as I started, I got to realize like we're doing so much testing, we're doing so many, we have so many people involved in making sure that we're doing the right thing that I don't feel as scared about the fact that we might mess up because we're testing it at every level a lot. So yeah, there's a lot of people. And one of the things that has maybe not surprised me, but I've been reminded of is how important interpersonal things are. So we used to call these soft skills in the flight control room, but the ability to lead your leader, the ability to speak coherently and write coherently, the ability to work well with others. Like there are some people that are difficult to work with, and they're an impediment to doing a good job, you know, on our project. And there's not very many of those people, but when you run into them, you're like, why are you being so difficult? You know, we all have to work together toward a common goal here, you know, and that's so important. So the you know, when I talk about flight control and stuff, I say that you know, the technical smarts is what gets you in the door, but your ability to be successful is really all about those soft skills and your ability to work well with others and your ability to communicate and really seek to understand what other people are saying. So that's the key to success right
I love that. I love that. It's people get tired of sometimes kids and well and teachers and parents and everybody else get tired of the group projects.
there.
I mean, it's like the bane of everyone's existence sometimes. And so,
Yes.
but this, I mean, this shows how those group projects are teaching you how to interact so you can be successful in getting things done later.
Absolutely. Yeah, I mean, there's
Yes.
no alternative. If you can't work well on a team, you don't, you're not going to be on this team. Like, I mean, it's not optional. You're going to have to
Yeah.
learn how to do that. Yeah.
Now,
Yeah.
you mentioned the weight.
I can.
The current design's a little heavier,
Yeah.
but I'm thinking,
Mhm.
but you're on the moon. So how is that impacted on a much lower gravity place like the moon?
On the moon, it's not a big deal, but we have to get there. And so it's actually because the vehicles are not able to carry as much weight. I mean, it takes so much fuel to get to the moon that we're really, really mass limited. So making sure that we're doing whatever we can to reduce our mass is important, mostly for the launch of the suit and everything.
Okay.
What what sorts of materials are used for a spacesuit?
That's a good question. Right now, we're looking at different things like aluminum or like a fiberglass. We really want to make it as light as we can, but it's a lot easier to make like a metal structure for the harder parts of the suit. So we use, you know, titanium and in lightweight metals. One of the things that has been really interesting is so if you're familiar with like diving, it's really when you're doing anything that involves a pressure change, you have to reduce the amount of nitrogen in your bloodstream, or you get the bends. And so we have to really take into account our oxygen saturation of the astronauts in the suit. And so to do that, they want to fly these vehicles with a lower normal pressure, like in normal air, it's 14.7 psi. We want to fly the vehicles at a lower pressure with higher oxygen concentrations so that we have to spend less time. We don't have to spend as much time doing what we call pre-breathe. And so we want to get all that nitrogen out of the system earlier. And so to do that, you increase the oxygen. But when you increase the oxygen, the flammability of everything goes up. And so we're really concerned about the flammability of different materials. So we're doing a lot of materials testing right now on what kind of materials can withstand that higher oxygen concentration. Because the last thing we want to do is, you know, have a fire in space or on the moon. And so we've got a project ongoing right now, testing all the different materials that we might use. But the suit materials that we use right now, the outer materials it's like a 5 to 10 layer sandwich of like a Teflon coating and a Mylar layer and some aluminum. You have a bunch of different layers that help keep a good pressure. There's a pressure bladder that's like a plasticky, flexible plastic kind of thing. And then there's the outer layers that are what you see, the white material that you see on a spacesuit. So that's kind of some proprietary blend of Teflon and nylon and something or other. But we're also we have a lot of requirements for what that material has to do. It's got to be non-flammable. It's got to resist moon dust because there's a big problem with moon dust. It's going to be a mess. And so we're trying to come up with the right kind of material for that.
What kind of problem is Moondust? I thought that was just
Well,
living room.
yeah, so we've been watching a lot of Apollo videos, especially with all the 50th anniversary stuff, and you can just see if you look in those videos, like they kick and the moon dust gets everywhere, and it gets on the suits, and the suit dust inside the seals of a spacesuit will make it fail a leak check. So you won't be able to hold pressure if you get dust inside the seals of the wrist bearings or wherever. Also on the vehicle itself, if you get dust on the seals of the hatch, it won't be able to hold pressure. Dust inside equipment, sensitive electronic equipment is bad. Pretty much everything that dust touches, it's bad. And it's this very fine, like electrostatic dust that just gets everywhere. So we've been listening to like the Apollo 17 mission, I think. There's a really cool website that has you can track like the actual, you can listen to all the loops and the crew and everything from several of the different Apollo missions. And we've just been listening to those, and they're like, man, this dust. I mean, they must mention dust like every couple minutes. It's like, this dust is nuts. So yeah, it's a big problem actually.
Well, that's you don't think about when we think about the.
I know.
Yeah.
I was surprised. One of the first meetings I went to was this big kickoff of our dust mitigation program. Like, wow, who knew that was a problem?
All the things you find out.
Yeah.
Now, one of the biggest things that I say a big, I should say, for society are actually spinoffs from NASA.
Yeah.
So, what down the road, what kind of spinoffs do you think will come from a redesign of a spacesuit that might impact society in other ways?
That's a good question.
I know mine are random sometimes. I'm sorry.
No, that's a great question. So the things that come to mind are, especially a lot with this COVID stuff. We have pressurized breathing systems, so we have people that know how to make ventilators and things like that. We could make, pressurized, sealed pressure suits for people, whether they were sick or the caretakers. I wouldn't want to be in an EMU or a spacesuit while you're doing that, but maybe some kind of spin-off of that. There's one of the challenges that we have in the spacesuit is a carbon dioxide removal, and so we have some equipment that we've, I guess, invented to maybe not invented, but perfected to reduce carbon dioxide using amines and stuff like that. So if there's ever a need for that, I know one of the things they're trying to work on is like a heads-up display for the suit. I know that the Navy has one that they're using for some of their Navy divers, and so like the inside of the helmet would have like your navigation, very Iron Man-y. So I could see that kind of coming along. So yeah, there's a lot of different things. Even just trying to come up with the materials that we're going to need that are non-flammable, that resist dust. I could see that a lot of applications just for construction workers. And firefighters and stuff like that.
Oh, that's great. Yeah.
You mentioned EMU Systems, and a while ago you said you are actually an ex EMU Systems Engineer. Well, are these letters that mean something? What is this?
They are. At NASA, we love acronyms. So EMU means the Extravehicular Mobility Unit. And specifically, EMU means the spacesuit that we have on space station. The new spacesuit is called the XEMU, or the Exploration EMU. And so that's the new spacesuit. So there's EMU and there's XEMU. those are different suits. There are other suits that exist in the world, like SpaceX is making a launch and entry suit that isn't really for spacewalking, but it's for the astronauts when they launch and enter, but it'll also hold pressure. We have a launch and entry suit for the Orion vehicle that's called the OX system, OCS, I think, or OCSS, I get those. And then there's a couple other suits out there that exist.
So will an astronaut have, how many suits does an astronaut have? That sounds like
Right.
a bad joke getting ready to happen right now. How many
It
suits
does.
does an astronaut need?
Well, that's a funny question. We're actually debating that right now. Right now, the plan is the crew will launch to either Gateway or to somewhere near the moon on Orion, which is a new vehicle that we're building and almost done with. They will have an ox suit during that, so it's designed to protect the astronaut during launch and entry. It's not really designed for spacewalking and things like that. When we get up into space, there's our current plan, although it may change, is that they will leave the Ox spacesuit in Orion, and then they'll leave Orion up in lunar orbit, and then they'll go into their moon vehicle, their lander vehicle, and in that vehicle they'll just have the XEMU, so the moon walking spacesuit. Because of those weight concerns we talked about, they can't really afford to take two suits, so they're going to try to do it all in the one XEMU. That may change when we get different moon vendor designs. We're not sure what they're going to propose. They may propose using their own.
All right, so Sarah's going to shake her head in a second because I always tend to go science fiction eventually. And
Okay.
I'm thinking of the sci-fi movies that I've watched and all these different ones, and you said leave it in orbit. And so I'm imagining, and tell me if this is any close to reality, you'll have a big spaceship that's circling the moon on its own or with a pilot, and then people get into like a small space shuttle thing and fly down.
Yeah, that's exactly what we're going to do. That's the
Wow.
plan.
That blows my mind.
So we're actually designing a new space station called Gateway, which is going to be a lunar space station. So we have the International Space Station that goes around Earth, and then there will be the Gateway space station that goes around the moon. And so everybody will gather at Gateway. This is one proposal. So the Orion will go to Gateway with the people, and there's not going to be, at least at the beginning, not anybody living on Gateway all the time like we have on Space Station, as International Space Station. So they'll go to Gateway, they'll kind of gather there. The moon vehicles will come to Gateway as well. When everything's all ready, that's when the crew comes. And then the crew gets into the lander. And then from Gateway, they go down to the moon. And then they come back up. Similar, I guess, to how they did the original Apollo missions, where there was one capsule that, kept going around the moon and with one guy. We may have we may have two people that stay on Gateway or the Orion vehicle while their friends go to the moon.
Oh wow!
Wow.
Yeah.
So,
And then the idea is that Gateway becomes a launching point for Mars mission.
oh,
Neat.
whoa! Sorry, that just blows my mind.
That's awesome.
Why are we going to the moon again? What are we hoping to find out?
Um,
I know you're focusing on the spacesuit, but
yeah, why? I think the real answer is because we haven't been back, and humans are a space, they're an exploration kind of being, right? So we explore. That's what humans do, and that's where we need to go next. Um, One of the other reasons is because we'd like to go to Mars for that same reason, because we like to explore. And before we go to Mars, before we add on the complication of not being able to talk to our people very quickly, we want to figure out some basics like how to live on another body, like how to live on a surface, how to deal with a little bit of delayed communications. Right now, it's pretty easy to get stuff up to the space station and back, but it's a lot harder to get it to the moon. So we're one step further away, and being better at not relying on the Earth to bring us stuff all the time. So a little more sustained separation So there's a lot of things that we can practice by going to the moon that we need to be able to go to Mars. And that's our stated goal. And then there's also things like mining on the moon. Like there are resources on the moon that people are interested in. I don't know that I want to promote that as our reason for going.
Yeah.
That is behind a lot of it. So
Fair enough. Well, exploring new resources is always an agenda somewhere.
yep.
That's just kind of the way that works.
Yep.
And that's how we get new technology. So I understand.
Yep.
But so it's like a
Yep.
stepping stone. This is so cool. It's like a stepping stone to the galaxy.
It is. Yeah. That's our first, and this is our first step. We have to start sometime and somewhere. So why not now? And
Good
it really
point.
takes a little political will to do it. And I guess we have that at the moment. We're gonna go.
Well, I'll be curious to see what kind of spin-offs come off, and I'll be excited to get a look at this new spacesuit when it's done.
Oh, well, thanks.
And this will be we have there on campus. We always have viewing parties and stuff. Anytime there's a launch, there's
Oh, cool.
one, if not multiple, large viewing
Yes.
parties. And so
Yeah, actually, when I was at Purdue, I was the president, I guess, of the Students for the Exploration and Development of Space, and I loved it. It was a great group. So yeah, that was a cool group to hang out with.
Yeah.
we always encourage students when they get to the university to find clubs, find something, because there's something for everyone, whatever they're interested in,
Absolutely.
people, and connect with them.
Yeah,
Yeah.
absolutely.
Well, we appreciate it. Sarah, did I cut you off on anything?
Nope. Nope. Thank you, Caroline. This is
Yeah, you're
awesome.
welcome.
Mhm.
Well, thank you.
Say we appreciate you taking time. We know you have a lot going on and you're busy. We appreciate you taking time for this interview so we could get this out there.
Oh, well, thank you so much.
Yeah.
This was a lot of fun.
Oh,
Thank you for listening to our podcast.
Be sure to subscribe, rate, and leave a review
An outstanding
on
review.
iTunes or your preferred podcast player.
Tweet us your science
At
questions.
Purdue SOS.
Until next time, be super and remember,
You are someone's hero.
boiler up.
Hammer down.